Okay, so thank you for attending the last talk of the day, or over the whole conference. It's been certainly interesting. I saw some talks, and over the talks I made some adjustment to my own slide because of relevant material, which is certainly a benefit of being the last one. Also a downside, you keep doing work. Well, a little bit about me. I've been a former contributor since 2012, which is a long time ago by now. I've been a Red Hat engineer since 2017. For those of you who don't know, Foreman is the upstream to Red Hat Satellite, or one of the upstreams. So all of this sort of flows into the downstream product, but I was a community member before. I've tried to keep the information in the talk limited. In the past, I've always tried to dive too deep. Let me know in the end if I actually succeeded or did too much. What is Foreman? Novar already told you, but it's doing host lifecycle management. It's extensible via plugins. The part she didn't really mention because it's too long, perhaps. There's a big plugin called Cotello, which is doing content management, which it's so large it also pulls in other dependencies. Like we have, besides Foreman and Foreman Proxy, we also have Pulp, which is written in Python. We also have Canopin, written in Java. So all of these sort of things put together makes a fairly complex packaging ecosystem. So we try to do it with a very small team. I think we have about 4 to 6 people who are actively involved in this, but even that is sort of beside your normal job and not really dedicated. So there's a large need to automate. I think for a lot of people it's true that you don't package because you like packaging, you package things because you want packages on your system to actually be a user. So yeah, the less time you spend on it, I think the better. For us, we've chosen monorepositories. I know it's controversial for some, so I'm not going to go into all details, but we have 3 for all the major applications, mostly because they have their own life cycles, and that just makes it a bit easier. And I'll go into details later. These are just terms I made up, but I want to focus on the development workflows and the release workflows. So basically anything that happens before you merge a PR is, in my opinion, development, and basically after is more the release work. That's just how I'm going to treat it. So let's look at development. We are based on GitHub. We use pull requests a lot. We do CI with Jenkins, and then we use COPR as a build service. And that basically tells us, is it all right or not? And if so, we merge it. There are some limitations we have. For example, one problem is that we build every package individually. So you can't really do something like, I'm updating a dependency and then also it's a build requirement, so I need that in the same PR. That's something we can't do. That's just complicated, and we decided to ignore it for now. It's good enough, but not great. We also try to do repo closure to see if it all passes. For those of you who don't know, repo closure basically verify if all dependencies are present in the repository after you build it. In my experience in PRs, it's usually not that great. It has some flaws in some technical details, so that's not a great check, but we still do it. As for branching, like we have the monorepository, and it's quite nice that you can actually branch the whole repository at once. So unlike Fedora, where you need to do 20,000 branches, we just do one single Git branch and sort of done. So we have RPM/develop for nightly. We have x.y branches for stable releases. There's some cherry picks in between those. Nothing special. I think most of people here know that. From the name, you might also derive there's something else than RPM, and yes, there is. We also do Debian packaging. But I'm not going to dive into it today. So sorry for the colors, but this is more of a visual representation. So we have the develop branch at the top. Then you create a new branch for your feature. You try it all out, and it eventually passes, and you merge it. Then at some point you have branching. So you create a new x.y branch. There's always some post-branching actions you need to do. For example, it's no longer 3.14, it's become 3.15. So that's something you do in RPM develop. In the stable branch, you remove all the nightly package building things. But then they live on in parallel, and that's how most people do it. Then you also have package bumps, for example. Very often you have a plugin and you also want to update that in the stable branch. So you do a cherry pick. So these are sort of, I think, the most common workflows that we do. This is fairly standard, I would say. Just want to go over it. Release parts. So we mentioned earlier, PR merged and you need to release things. This is, I think, fairly simple. We basically have Git. Jenkins monitors Git and figures out what changed after something was committed. It sends up jobs to COPR, builds it, and that's sort of what we do. And we treat COPR almost like a dumping ground, just as going to be next version. It's a more continuous process. I think that the interesting part comes after that, release pipes. Because this is really the more interesting part. And if I saw, like I mentioned earlier, some interesting talks which had a lot of overlap. In Troy's opening talk, we saw CentOS as build pipelines. They're pretty similar to this. It's basically the same thing. Then Andrew said the same thing for Alma Linux. They do the same thing again, and we do the same thing again. And when I was talking to other people, apparently other people do the same thing. So it shouldn't be too surprising. So this is how we did it. We have a compose step first. This is where we take all the builds that we did in COPR. We gather them up. We do our own magic on top of that. We put it on staging yum.theformer.org, which creates a snapshot we can sort of rely on. It's stable. We also do some other magic. Apparently our interpretation of comps is different than what COPR does. We also treat it as a filter, so we can filter out packages we don't want. Apparently COPR does it different, because COPR also creates repositories, but we can't use those. Another limitation is modularity. COPR didn't really do that, so we need to do our own. Luckily, in Nightly we've dropped EL8, so we don't deal with modularity that much anymore. But still, on EL9 we need it for some things, so it's not entirely gone, if only. So I mentioned repo closure in the past. That's also what we do as a first sort of sanity check. It's fairly cheap, but if that doesn't pass, there's no point in actually going further with testing. Then we have a testing phase. It's a bit simplified here. What we do in practice, we have, generally speaking, 2 pipelines install. It says what it does. It installs basically a base OS, runs a Foreman installer on it, and runs a bunch of tests. And we do that for multiple versions. So for every EL version we support it. Currently only 9, but previously we had both 8 and 9. And then for every, we also do it in CentOS Stream, but also we run it on Alma Linux, so we know we are sort of compatible with RHEL. It's just a stand-in, and Alma Linux is easier because it's freely available and you don't need to deal with subscriptions, etc. We also have upgrades. Upgrades are basically what we do is what you call N-2. So we start, let's say that we are testing Foreman 3.14. So we start with Foreman 3.12, we install that, we upgrade it to 3.13, then we upgrade to 3.14 and run the same test suite to see if that still passes. So it gives us some sanity if it's still sort of working. Often find interesting bugs that you didn't expect before. So I'm very happy to have that. And that does the same matrix testing, like the same OS versions, the same distributions. This all runs on CentOS CI. We basically use a big beefy machine, bare metal machine, spin up a bunch of VMs on it, and because it's doing that, you can actually reproduce it locally as well. It's exactly the same, just spin up Vagrant, spin up boxes, and you can reproduce errors. And I think that's proven very useful in the past. When something fails, you want to dive in the exact same environment. This gives us that. But I saw a lot of similarities with compose testing. Currently our tests are mostly written in Bats, which is a Bash framework, and Bash is not really a great tool. I saw that CentOS uses TMT, and that's something I'm investigating, but I don't know. But it sounds very promising to sort of standardize these kind of pipelines. And if all the tests pass, we're happy to promote. So we promote the content that we had on staging yum.theformer.org. We promote that to yum.theformer.org, and users can actually consume it. This is one pipeline. We basically do this for every repository that we create. So it's basically the same pattern over and over again. Also for stable branches, etc. Let's zoom in a bit on the individual repositories. So we have the Foreman packaging. We actually create 4 repositories from one Git repository, partly for historic reasons, So we have the core, which is basically Foreman itself, Foreman proxy. Plugins are built on top of that. They have a bit different life cycle, and that's why it's built on top. And Catalog built on top of that again, mostly again for historic reasons, I would say. But it's still done this way. And we also have a client tooling package package repository that we publish from it. Lifecycle wise, we branch every 3 months, so we do a bunch of procedures around that to make it easy, reproducible. For those of you attending a confirmation camp on Monday, I'm doing a talk on that there. But that's more a different level. This is more technical on the packaging side of it. And like I mentioned earlier, we had Pulp Core and Candlepin packaging as well. They're basically the same thing, except that they're a bit simpler. They have their own life cycles, but pretty much the same setup. Right, so what are some common actions? I think every packager knows these. You want to add a package, you want to update the package, remove it, build it, and you do release-related work like branching, etc. So how do we do that? Well, we have a bunch of tooling. We still have a bunch of local scripts, shell scripts that everyone starts with, and they got out of hand. So there's some packages, some scripts to add packages, some to do bumping, to release a new version, to remove stuff. And then we also have OWAL, and it's an Ansible wrapper, and the Czech speakers here might recognize the joke. OWAL is the Czech word for wrapper. It was intended to replace all local scripts. Given that we still have the local scripts, you can see we're not quite there yet. But the whole idea behind it is you have an Ansible inventory, and every entry in the inventory is a package. So basically that gives you a way to easily do bulk actions. Basically you run Ansible on all of those. Basically you can say OWAL release, package name. But we also have groups, so you can basically say release everything in the Foreman group or the plugin group. And that's proven quite powerful, especially we also introduced tiers, because everyone here knows that when you bootstrap a new version, you have some build dependencies. So we introduced some tiers to say, well, this is basically the first build dependencies and create those. So that's something that's proven quite useful. And you have Ansible variables because you have all the power of Ansible. So yeah, that's the tooling that we have. I already mentioned we still have a few local scripts. They're fairly simple on how you call them, but they very heavily rely on the gem to RPM, pip to RPM, and npm to RPM. We also have our own templates. So you have for gem to RPM, we have the default template we have for any gem, but we have a specialized one for any Foreman plugin. So because they have more complex build steps, and this makes it quite easy to add new things as we go along. The bumping is also something we use quite heavily, which is actually the next topic. Adding robots. We automated version bumps, and I already saw the Packet talk earlier. We do a similar thing, maybe our own version of it, because we have a mono repository and Packet works on individual repositories. But I think this one really saves us a lot of time and effort. So it's implemented as a GitHub action. And the strategy is quite simple. It's basically for every updatable package you create, they run in parallel. So it does a checkout of the source code, does some setup steps, it does actual bumping, the bump rpm.sh script that we saw earlier, and then it creates a pull request. And that's basically what it does all the time. And this runs in a cron job. We run it twice a week. We don't run it too often because sometimes when it does a bump, it's not perfect. Something changed in the source package and you want to fix it up. If it runs all the time, it sort of overrides your local changes all the time, which is inconvenient. So that's why we run it twice a week. But this saves a lot of effort. So what to update? That's the updatable part. We have a list of supported leaf packages. Basically, the Foreman plugins, you always want the latest version in nightly. So whenever a new version is available, just put it in. We also have the gemfile.log. In the Ruby ecosystem, you have bundler, and it creates log files. And you can sort of inspect all the dependencies that it has, and it has pulled in. And we put all those together and sort of figure out what do we need to update. And that's what we did with the buildable, updatable list. There's some conflict detection. For example, one gemfile.log might pull in a newer version than the other, and everyone knows how annoying those are, but we do some detection and we simply don't update it and sort of yell at you, I had a conflict. But yeah, that's generally speaking what we do. I would say it works quite well. But then we had a problem, we have multiple teams. Because like I mentioned earlier, we had the Foreman plugins and we actually have multiple plugin maintainers and every team can merge their own PRs. But how do you do that if you have one mono repository with multiple owners and you don't want to give them full access to everything? GitHub implements code owners, so you can say these files are owned by these teams. It pulls them in as a reviewer, and you can define rule sets to mandate reviews, so that they must approve their building, or one of those owners must approve, and only then can you merge it. You can also do some additional steps, like the Foreman packaging team, they can bypass checks and just do what's needed, but the individual plugin teams don't. So this is something we recently introduced, and together with the automation, it works very well because a PR is opened, they are automatically added as a reviewer, they get a notification and just need to merge. So that's the whole update cycle. It's a bit easier for them and no manual work involved anymore. So I see the timer wasn't started, so I'm not sure how I'm time. Okay. So reflecting, I think good. Standardized workflows, I really like them. Because we're a small team, it helps. The automation helps a lot. It saves a lot of effort and time. I think the templates make it easier as well, because spec files, there's still a bit of a thing you need to learn, and we have plugin maintainers, they don't want to be packagers, they just want to ship their code to users. These things help with that. The reviewing of the generate PRs, also very, very useful. It makes it so easy if you can just, in the morning you get up, you see a PR, you see CI already ran, you know it's good or bad. No more waiting, just approve it if it's green and merge it. Otherwise you fix it up. I like that a lot. But as I mentioned, the bad, I think packaging, it's still a specific knowledge set. When it breaks, it's not obvious to everyone what actually broke. I think that's where you very often still need people with more experience to help the individual plugin maintainers or newer people. Other things, runtime version of Ruby, Python, NPM. EL still has its own life cycle, which is complex. Also, we try to do updates. We support upgrades with leap from EL8 to EL9. You need to align some things, and for example, Postgres you can only upgrade from 13 on because EL9 only understands 13, so those kind of things. But overall, Ruby and Python is really the difficult one. And we've used SCLs and modularity, but in practice, I was never really that convinced with them. It's very often it feels that when we use them, we were the first persons doing that thing with them, that we were exploring the solutions, and we figure out, then you talk to the maintainers and say, well, we've never tried this, and it was always painful. You always need to work around things, and that's why I'm happy that, for example, with Python in EL9 at least, you already have versioned packages that can be co-installable. It's way easier. I hope the other ecosystems do the same thing. And then the ugly. I mentioned there's a good thing in templates, but I also said it's ugly. Because I personally think that if you copy code all the time with templates, you're duplicating things, and you need to keep it in sync. And I don't like that. I don't like duplication. So I would like to see more solutions which are more generated. And RPM is doing some things of that. Like runtime requirements. You can generate them dynamically, already saves a lot of duplication. Build time dependencies. We don't use them yet because we were very late, or we recently dropped EL8, and until then it didn't make a lot of sense. But I'm looking forward to use them as well to remove even more duplication. But maybe there's more we can do and push more into a system where you use something that's not duplicated all the time and centralized. Also ugly, we never completed the transition to OBOL. Would be nice to finish, but time is always limited. So we have some local script for, like I mentioned, the update Python package. We actually call that from Pulp core packaging. It lives in Foreman packaging, and it's never nice, but the way we live. And the release cycles are still hard. CentOS Stream is still not the perfect upstream to RHEL. It's certainly a very nice thing, but very recently, for example, we had RHEL 9.5 where there was a Java update where suddenly Kohl mandated the parameter. And that change didn't go through CentOS Stream. So when RHEL 9.5 came out, it broke on all versions. So that's... I like the concept of CentOS Stream. We just need to complete it. So there was some yelling at colleagues that they shouldn't do that anymore. But yeah. So in conclusion, automation is great, helps. Bots are nice. Maybe we should do more of those. I saw a few solutions here at the conference that I really like to try as well and make our lives easier. Templates, they help. And monorepositories, I think they help us a lot in doing easy bulk updates and making things a bit easier. Especially because, like we didn't mention before, but we change our Python version or Ruby version, and if you need to do that across all of the different repositories, that's quite hard. If you drop an OS version, it's quite hard. In monorepository, it's quite a bit easier. So for us, it's a great thing. And with that, I came to the questions. Yes?
Hi, this is really interesting. We have something kind of similar at work, but not using RPM. One question regarding, you mentioned you use, so basically it's mostly Ruby gems and Python and NPM for Node.js. For NPM, do you package individual modules or do you basically vendor? Because in Fedora we gave up on...
and I completely understand why they gave up. I didn't want to spend half an hour ranting about NPM. Because I completely understand why Fedora gave up. It's we sort of came up with a solution where we bundle a lot of things, and I think it's sadly the only sane thing to do with how NPM ecosystem works, which is sad. But yeah, these days it's a web application, you can't really get around Node.js. Okay. Thank you. These are the URLs that we have. And I think I'm doing well on time. I had some more thoughts that I sort of backup slides if I went fast, because I usually do that. So I had some thoughts about where we can go in the future. Like, could you actually include repo closure in COPR itself? So it already does that and becomes more of a build service for you. Another thing is like the promotion pipelines. That's essentially what COPR could do. It's these days it's already backed by Pulp anyway, so it should have a lot of those options to create that snapshot. You test on it and then promote it somewhere else. So maybe that's a great COPR feature as well. On the other hand, maybe we'll move to containers in the future. Who knows? And I saw a lot of conflicts talks. Maybe that's more of a direction we'll head into. But yeah, that's some things that I'm sort of thinking about. Other things, RPM autospec, that's not something we can probably use because you have this monorepository, and if you have this bump commit that's empty, are you going to release all your packages? What's going to be, I think it's going to be, you can probably do something with for parsing the commit messages, but I don't think you really want to get in that. So for now, we always have the complete change logs in our spec files. But yeah, that's maybe also something to think about. The last is nightly packages. So we do this weird thing where we build packages. We don't update every single nightly package. We simply take the spec file, we change out the tarball, and we build those. And only when we get to the final releases, we actually build proper nightly proper packages. It always feels like a bit of a hack. We change some things like the release field, so we know which Git build it was, but I'm wondering if we could improve on there as well. But for now, it worked for a few years, and it helps a lot with some packages to have nightly, because developers want to see their changes quickly, and it helps. But the biggest downside is that you have this part of it that lives in Git and part of it doesn't. So if you do this for every single package that you have, like every single plugin, the whole bot to automate the package updates and then cherry pick those, that sort of breaks because you now have this, it shouldn't be tracked in Git. So that's still something I'm debating. And the last is build routes. We actually use rel build routes for compatibility, so we can actually deploy on also rel and Alma Linux, because as Linux policies have this weird thing where you include the version, but if CentOS stream updates to a new policy, you can no longer install on rel. So that's why we use rel build routes. But that's also meaning that you don't completely take the benefit of testing on CentOS stream. So do we actually need to build everything twice? So those are some thoughts that I've had, and I think they're open questions. If people have more answers, I'd be happy to hear them. But yeah, these were my bonus slides. And with that, thank you.